All right, I know what you guys are thinking. You're saying, Mrs. Weber, what exactly do we have to know to do, right? Because you only want to know what you have to know, right? Well, you need to know three things. You need to know how to evaluate the limit graphically, numerically, and algebraically. All right. Now, graphically, you guys are pretty good with. All right. We have our function here, x squared plus 3x plus 2 over x squared minus 4. If we look at the graph of that, let's factor first. We get x plus 2 and x plus 1 over x plus 2, x minus 2. So we know that there is a whole at negative 2. When we plug in negative 2, we get what? Negative 1. Negative 1 over negative 4, so that's a positive 1/4. Okay, so we have a whole right here. All right, and then we have, if we look at the asymptote, x over x, when we're dividing, we're just going to get 1 for horizontal asymptote. And then we have a positive 2 for our vertical asymptote, x equals 2. Okay, and let's see, intercepts. If I plug in 0, I get negative 1/2. And then I would have negative 1 right here. So I think it's probably a safe bet that this branch is going to be going down on the left side, and then this is going to be going up. The power of this is 1. So since this goes down, we have to be on opposite ends. So even though I don't know any values on this side, that's okay, because I know that the branch is up here. So as I am approaching infinity without bound, or as x approaches infinity, this is saying when x gets really, really large, what's happening to the graph? It's getting closer to that horizontal asymptote. So as a result, we know that it's getting closer and closer to 1. So that is graphically. Numerically, what we're going to do is put this into y1, and we're going to type it all in. And what happens is when we evaluate 100, you get 1.0306. You put in 500, you get 1.006. You put in 1,000, you get 1.003, and 10,000, 1.0003. So you can see as x gets really large, we're getting closer and closer to 1. So that's your numerical method. Algebraically, you guys probably tried to forget this, but we actually had a kit on what to do here. And what you're going to be doing is you are going to divide by the term with the highest degree in the denominator. And when I say divide, I mean we're going to divide everything. Okay? So for this, we have the limit as x approaches infinity. We take a look at the bottom. X squared is the term with the highest degree. So we're going to, on top, we're going to have x squared over x squared plus 3x over x squared plus 2 over x squared over x squared over x squared minus 4 over x squared. Okay? And what happens is then we get the limit as x approaches infinity of 1 plus 1 over x plus 2 over x squared over 1 minus 4 over x squared. And as we evaluate and take a look at what happens as x gets infinitely large, well, nothing happens here to this 1, but when x gets really, really large here, remember, any number divided by a really large number is going to be approaching 0. Same thing, going to be approaching 0. And then on the bottom we have 1 minus, and then as we have 4 divided by that, it is also approaching 0. So as a result, we get 1 divided by 1, and evaluating this limit algebraically, we get 1. Okay, so the big thing to remember here, as we have any number that's being divided by a really, really large number or a really, really small number, so x as it approaches negative infinity, okay, those numbers are going to look like they are going to be 0.